Hey, ROS developers. Here we are here again with a new presentation, with a new webinar where we are going to talk about how to move from one idea of a robotics product into the product itself to the market. So I'm going to show you the process that we have followed in order to create a robotics product that is at present is a product that is being sold and that is working on some cafeterias here in Barcelona. And it's the process that we have followed in only 3 months. So it's we have shortened into 3 weeks because it's about the 3 webinars that we are going to do. So let's go for it. And so basically, that's the goal of this webinar, to show you how to build this robotics product ready to the market in a very, very short time. And what you will learn in those webinars, series of webinars that we have 3 of them, this is the first one, is which materials you are going to use in order to construct your product, which parts to buy and build, because not only you will have to buy materials, but also to build your own ones, and which software to use and how to develop new software that you may need. And that's all. So in order to get your product ready in a record time with the minimum amount of development, we want to reduce as much as possible the development. So why? Because by reducing the development time, we can go to the market faster, we can have faster maintenance times, and it's always about speed here. And also we'll be applying the mentality of reusing as much as possible of everything that is available, either on the physical realm or on the software realm. And we want also a product that is easy to maintain. So we don't want to build a product and afterwards it's a nightmare for us to maintain and to have modifications, corrections of errors, etc. So that's the product that we would like to build. So I would like to start by doing a disclaimer first, is that this method is to get a simple robotics product to the market fast. This is not a method for building the latest humanoid robot that it will go to the moon and then colonize the whole moon and build a society there. I don't know why. But it's just for this specific type of product. Okay, so that's my disclaimer. Having said that, let's see. This is, let me introduce you with Barista, the robot. This is the robot that we have built by using this method. And it's a robot that we call Barista because it's the robot that brings the coffee to the tables in different coffee shops. So probably you already know that there are those kind of coffee shops, like in this case it's Costa Coffee, but there is the same is the same style as Starbucks, the Starbucks type of coffee shops, where you have to wait there on the line in order to get your coffee, and then afterwards you can go to the tables. So what we identified here is a possible product where you can go straight to the table, and then the human person that is building, that is preparing the coffees, can send your drink to your table. So you don't have to wait. You can start reading, using the laptop, talking to your friends, whatever. The robot will go to your table and bring you the coffee when it's ready. So you don't have to wait. And then the robot will return back to the place where the coffee maker will put other coffees for another client. So this is the product that we have built. And by the way, I would like also to introduce myself. My name is Ricardo Tellez. I am the CEO of the company, the Construct. At the Construct, we build those robots, but basically what we do is we build tools for building robots, for programming the robots in an easy way. That's what we do at the Construct. We teach how to program with ROS, how to develop your programs, how to debug them, and how to deploy them into the robots without having to buy the actual robots. That is our company about. But today here now, we are not going to talk about the company. It's about how to build your product. Okay, so let's go for that, and let's go step by step of this method. Let's go to the part number 1. The first part is the outline of the project, and this is basic. So you have to start by outlining the project in order to understand what you want to build. So let's go. First step in outlining the project, the first step inside this part is to identify the task that you want to solve. So, for example, in our case, that we have the barista robot. What we wanted to solve is how to bring the drinks to the tables at the coffee shops. So that's the task that we would like to solve. It's a simple task, and it's a very, very clear task where we identify that we have some chance to use a robot to solve that task, and that we believe that the technology available already can be used to solve this task. So let's go for your case. So let's make a list of possible tasks to solve that the people who are listening to this webinar. So tell me your ideas, examples of tasks that you would like to solve. Please write them on the chat and let me know which ideas do you have. So I'm going to look into the chat. So I'm going to change here and go here. Here I'm watching now the chat. Probably you already are watching also the same screen that I am seeing. So, and then, yeah, I see here that Chris Mercier is saying, hey, a barista, it's a server. A barista is a person who makes the coffee. That is right. Barista is the person who makes the coffee, but we call barista because it was nice, you know? So Matt Drotter is saying, drive a path and take picture at different locations. Okay, so let's write it down. Let's copy this from Matt Drotter. So let me just copy and put it there. So they have to be simple ideas, okay? Because otherwise, if they are too complex, they are not possible to be accomplished. So we have here the idea, drive a path and take a picture at different locations. Okay, what is this useful for, Matt? So you have to think about that. If people is going to have a interest on this, I don't know because I don't really know your whole idea for a product. Then we have Chris Messier, personal assistant robot using Google Assistant API. Must be more specific. What, Chris? I'm not going to copy your idea because it's too broad. You have to be more specific. Otherwise, you will get lost in the amount of things that your robot will have to do. Remember that we are talking about robots, okay? We are not talking about apps also. So Jasprit Sign says, locate people to deliver their specific order. Okay, so yeah, I think it has still to be more specific. Locate people to deliver their specific order where? In a city or in a I don't know, in a building, something, just to specify a little bit more. Anyway, I'm going to copy that one because it's almost specific. Please, Gatspreet, define this more. And then the next one, let's see, it says clean the floor. For example, Jorge Vargas. Yes, that's very easy. Yes. Okay. Okay. So clean the floor. That's very specific. Clean the floor. And we have, then we have Sterling. It says, generate 3D maps of residential homes for allow virtual tools for people buying homes remotely. That is very specific and very clear, and it's also achievable. Okay, so I'm going to get this and write it here. Sterling. Okay, great. So we have, whoops. So we have several ideas. No more space here for the ideas. So thank you very much. Let me just read the other ones that still remain. Chrisman Kumar says human following shopping cart, which can be used in supermarkets. Okay, yes, to follow, and then you just indicate information. Do indoor navigation in library. You have to indicate for what. Indoor navigation in library for what? Do mapping and keep tables at location points. For what is the purpose also at Tuluru? Then Martin Petrovic, use sensors to move around the coffee shop, then park near table the robot is sent to. Yeah, so that's exactly what it's doing already. I was talking about especially other types of tasks, okay? Okay, so avoiding obstacle, localization objects. Okay, yeah, so it's okay, this. Let's continue. So you got the idea about identifying the task to solve. Then next thing. So let me check if this starts again, the slideshow. So let's continue. And then on the second step is to identify the constraints. You have to specify some constraints for these tasks. You cannot make the robot work in all possible conditions. So the constraints are about in which specific situations the robot is going to work, is going to deliver this task. So let's see, for example, in the case of the barista, the robot, the barista constraints that we have are the following. First, the robot must work on a flat surface. So it cannot work in a place where there are stairs. So if the coffee shop have different stages, we are not working for that. Or if the floor is not flat, if it has some uneven terrain, then it's not going to work. Then another constraint, it's going to provide only drinks in cups. So we are not going to serve any drink, any coffee, any tea, any whatever, any juice in a mug, for example. Only in cups, in closed cups, actually in paper cups. So those typical paper that are to take away cups. This is one of our constraints. Then the table, the robot can only go to fixed table locations. So the robot is not going to look for the people around and some days go to one place for serving these drinks and another day for another one. So the tables have to be in a fixed position and the robot must know this position. So why are we doing all those kind of constraints? Because if we don't set a certain constraints, we will not be able to build the whole product. It's very, very common to think that you can do everything with the robot, that you can solve all the tasks, and probably you can, but not in the amount of time that we want to do it. So the more the constraints, the better. So let me know some of the constraints that you will think that you will apply to your ideas, the ones that you have put before on the chat. Let's go again and let me know. So which kind of constraints would you like to apply to your robotic product? So let me know here on the chat. For example, there was a task that was, let me check the task first. It was drive a path and take picture at different locations. So this is for math. So maybe one of the constraints could be to just when you are moving inside a museum. I don't know. So maybe just inside museums, because that is very clear for the space that you would like. So, for example, and then here it's a flat surface. Then via Yashri cannot work in areas with a lot of light. Okay, so let's write it down here in indoor places. Let's say only for indoor places, for example. Then total dimension area of the cafe area. Yes, that's another possible. So let's copy here, total dimension area of the coffee area, for example. So it's a restriction. Shopping cart should have a limiting weight it can support. Or Matt is saying driving outside. Outside, this is too broad. It's too big. Outside is you should specify better, because it means driving outside. You mean that it can be done in any place. So it's too much. Then instead, Jorge Barja says clean inside the real living room, or Alexander Baranov work inside the underground parking area. That's perfect. Those two are very good. So let me just copy a couple more here. Shopping cart should have a limiting weight, and clean inside the living room. We already said some from Jorge, so let's write the one from Alexander Baranov, just to change a little bit. Okay, great. Thank you very much, guys. So let's continue. So you have an idea how to identify the constraints. Okay, so this means that the robot cannot work in all the possible conditions. This is never going to happen. So please take this out of your mind. The more you identify the constraints and the more constraints you put, the more likely is you are going to succeed in building your product. Okay, so step number 3, once you have identified the constraints, you have to reduce the things that the robot can do. Yes, I know that you want your robot to do everything, and you want the robot to talk to you, and you want the robot to recognize you, and you want the robot to suggest for another, connect to Google Maps and find this information that is around you and then provide that to you. Yeah, I know, many things, but this is not possible. You have to concentrate on the concept of building a minimum viable product. This is a concept from lean startups. It consists of building just the simplest thing that you can, the fastest as you can, in order to show to the world that your robot is doing something. And then you will be able to observe if the world is ready for your product or not. And then if it is ready, then you can build all the other things. But in order to get this product as fast as possible, you have to reduce the amount of things that you want the robot to do. Okay, so for example, for the Barista robot, we were asked, hey, when we were developing, hey, can Barista detect when drinks are taken from it? So then it will detect when the people has taken the drink, so it can return automatically. The answer is no. So now Barista goes to the table and then it waits for a certain amount of time. That is a fixed time. If you don't take the drinks on that period of time, then the robot will not know. Just return back to the place where the coffee is made. Oh, yeah, but that is not. Yeah, that is what it allows us to produce the product in 3 months. We have many months ahead to improve that. So can Barista detect when it is in front of the person? No. The robot just goes to the table at a fixed position, always to the same position for a given table, and then it stops there. And it doesn't look if there is the person looking at it or whatever. No way now. Hey, but wait, can the barista say, please take your drink when it has reached the point? That is it. No. Again, no. Because you are making, yes, I know that's easy, but that's a lot more of work that has to be done when even we don't know if the rest of the world, the basic work, is going to be useful. So people is going to like it. So it's a lot of work that we don't need to be done. So that's what I mean by reducing the things that can do the robot. So you have to take this into account, and you have to reduce the things that you would like your robot to do. Okay, so up to this point, we have identified what we want the robot to do. Then, in order to solve the construction of that robot that will solve this problem, then the next step is to identify and find the robot parts that we are going to need in order to build that robot. So if the robot has to move, then we'll have to identify that we need a robot platform that moves around. If the robot is going to be attached in a wall, then we'll need different parts. You know what I mean. You understand. So the first step on getting all the parts for the robot is to find the robotic parts. And what do I mean by the robotics part? Well, the robotics part can include several of things like this. The sensors that the robot will have in order to detect what it needs to detect, and only those things that it needs to detect for the task at hand, nothing more. So we are not going to put a camera in Barista to detect the faces, for example, because we are not going to do that. We are not going to detect faces, so no camera. Then we have, for example, the actuators. So can we put an arm into the Barista that can take the mugs and the cups and provide to the people that has requested the drinks? So the client, no. So actuators, 2 wheels. That's all. Finish. Okay, so for the CPUs, the CPU, it means the computer power that you are going to need. So you have to find which kind of computer you will like to have. And then it may be the case that you need just a small quantity of power. So for example, you can have an Arduino, or you can have a Raspberry Pi. It's enough. In other cases, maybe you would like to have a computer inside. That's okay. Then maybe you need some, for your robotics part, you need additional electronics. Those are specific cards of electronics that you will need for interfacing with some functionality that you need specifically. Like, for example, maybe you may need an IMU sensor that provides you with acceleration, or an electronic compass or something like that. So those are additional electronics. Also, what I suggest is that you take those electronics as parts that already exist, not for you to build, because that's a nightmare and it can take ages to debug those kinds of electronics. And then finally, the mechanical structure, that is the mechanical parts that will support all those things, all the sensors, actuators, CPU, electronics. So you have to have a physical part where everything is stored. So what I suggest is, for the robotics parts, any of those, they have to be ROS compatible. So if you select the CPU, please be sure that this CPU you can install ROS in that CPU. So if you are using a computer, then you will have to install Linux in order to get ROS. But that's okay, you can do that. If you have a Raspberry Pi, you can also install ROS in a Raspberry Pi. But if you build your own microcontroller with whatever, etc., so this is not possible to use ROS. So I do not recommend. Why? Because you are limiting yourself to the software part, that we are going to apply the same processes here. We are going to use as much software that is done as possible. And ROS provides many software that is already done for most of the functionalities, as you will see in the case of the Barista. So for finding robotics parts that contain support ROS, that are compatible with ROS, I suggest you to have a look at this online store that is called roscomponents.com. If you go here, you can see it's a shop that sells all kind of sensors, actuators, mobile bases, etc., and contains all the products that are here are certified that they will work with ROS. There is a driver to work with ROS, and actually they do also provide. So where this is the place where we have bought all the material that we needed for the Barista robot. And this shop is not related at all with the construct. It's just a shop that we believe that is quite professional, is very professional, and they deliver very, very well. So I highly recommend you to have a look at this. So this is the place where I recommend to buy, at least to start there, because you will see that it's just plug and play if you buy the products there. Okay, so we have no commission, okay, if you go there, so it's up to you. Okay, for Barista, let me show you the Barista, the robotics parts that we needed. In this case, we needed the mechanical structure of the robot. The mechanical structure, we decided to use the turtleboard robot because that provided already with the wheels, with the gears for the wheels, with the control, with the batteries, and everything is already done. So if we use the turtleboard robot, all that part is already done. And we saved a lot of time. So we use the mechanical structure, the turtleboard robot. Then as the sensors, we use one single sensor, that is the laser URGX04, is this one here from Fokuyo. Then for actuators, we use none. Actually, we have the actuators that are the wheels, but we included this into the turtleboard robot structure, so it's nothing. The robot does nothing as actuation. And then the final one is the CPU. So for the CPU, we decided to use an Intel NUC that is a very small computer, and we put it inside the robot and in a very short space, as you can see here, inside this area here. So the computer can be located there without a problem by using this. And also we have the power of a computer. So we are not using a Raspberry Pi or another like Arduino, etc. So if you have Arduino or Raspberry Pi, you can also use ROS on them, but it's a little bit more complicated. So you're putting more rocks into your path to make it more difficult. But it can be done also, okay? So it depends on the project. It depends on the project. Okay, great. The second step in getting all the parts for the robot is to find the decorative stuff. So you cannot build a robot just with all the parts, all the cables around there, and then provide this as a product. So you need some way to find decorative stuff that provides to your robot with the aspect, with the looks that it's a real thing. It's a real product. It's not something that you have created in your lab and that's all. So that's for the case of the Barista. As you can see, we have you can identify the structure of the turtlebot, but we have covered it quite well to make it look nice. So the people that is looking at it at the cafeteria, they like it very much. As decorative stuff, we can include several types. Covers, of course, the covers. You can see here the covers that cover the structure of the turtlebot, also the laser, and the cover on top that allow us to put the mugs. So then you have graphics. Like graphics, for example, we have this label here that says that the construct, but on top of the robot here we have another label with the mark of the company of the coffee shop, etc. So you may need this kind of graphics in order to put around your robot and make it look great. And then also some addrezzo. In this case, we use this, I don't know how to say in English, it's this red stuff, bow tie. bow tie on your here in order to provide a distinguished aspect into the robot, like it's the real person that is bringing to you the coffee. And then finally, I have added this about the lights, but because everybody wanted to put some lights on this robot, but as I said previously, if it is not necessary or mandatory, you should reduce that. So lights are only should only be added in case that those lights provide a certain utility, that without this utility, then nobody will understand what the robot is doing. So the job of the robot cannot be performed. If it is a nice to have, then you have to discard it. Okay, putting lights on a robot then increases the complexity a lot, because you will have to put all the systems, the electronics and the batteries and etc. that provide the lights. It's not just putting the lights at some point and that's all. So it complexifies, it makes it more complex, the creation of the robot. Okay, so then for how we have done all that. Okay, for the decorative stuff, what I suggest you is that you find a graphic designer. So you need somebody that knows about design, about how to make things look pretty, and then work with them in order to deliver you some covers for your robot that make the product very attractive. I can show you here the example with the Barista robot, and that was the original idea from the graphic designer. Of course, afterwards you do what you can do, of course, but this was the original idea that the graphic designer get about, and we try to replicate this as much as possible. And you can find good graphic designers for a very decent price at this website here, https fiber with 2rs.com. Then once you have done the graphic design, that is this one, this is a graphic design, so it's a conceptualization. Then you need to find a 3D designer. The 3D designer is another person usually that converts this graphic concept into a 3D model that can be printed. Because for the decorative stuff, what we are going to do is to print it with a 3D printer. We need to provide the robot very, very fast to the market and do tests to see if it is accepted by the public and the people likes it, and where it fails, etc. So for that, the fastest way and the cheapest way is to print it. So once you have the design, you need a 3D designer that converts that design into a 3D file that can be printed. You can also find 3D designers at the same web, fiber.com. Then finally, once you have that, then you have to print it, of course. Then the one place that we used for printing is 3dhubs.com. It's very, very nice place where you can find a local 3D printer that prints at your location. So, and they are, all of them, they are registered in this hub for 3D printers. So it's very nice web and useful. That's a place where we found the people who printed our Barista design here. Yes. Okay. Well, this one. Okay. So in this case, we had to print two parts. Okay. One is the bottom part here, and the other one is the top one that contains the holes for the mugs. Okay. So now you know how to find the decorative stuff also. And then, of course, you always reduce the things to build. If you want to be on time, you want to have the product done, you have to reduce. Please have the integrator mind. This means do not decide to build the board for controlling the speed of the robot with this specific microcontroller that you like so much. Yes, I know you know how to do that. I know you are a very good engineer, But that's not the point here. The point here is to produce the robot very fast. And for that, you need to use as much as possible that is already done. So that's the integrator mind. Find what is already existing there and then just put it into your robot. So you have to aim of buying those parts, not at building them. Again, I know you are a very good engineer. I know you want to build the things. Yes, I know, because I feel the same. But this is not the point here. So we are not discussing about that. We want to build this very, very fast in a very cheap manner and maintainable manner. And for that is to buying things that already have demonstrated to work. And the more you buy, that's mathematical. The more you buy, the faster you will move, because you only have to order and then you have it. Otherwise, to build and make it work in a robust manner, that's very difficult. It takes a lot of time. And of course, the same thing applies for maintenance. So if you have bought things and those things they break for whatever the reason, just have to replace, to buy another one and just put it there. Otherwise, you will have to debug and find where in your boards your problems is, etc., etc. By buying the stuff, you know that the stuff is working. So if it is not working, it's because it's wrong. Then you just replace. Basically, that's the situation at the cars right now. So there is a guy who goes there, plugs some device that detects which one is the part that is wrong, then goes, takes out the part and puts another one, and that's all. They never repair the parts. So you need to reduce the things to build, otherwise you will not be on time. Okay, so part 3 is the final part of this first episode. It's about to decide the software to use. So up to now we have decided what the robot what the robotic product has to solve, the task to solve, and in which conditions, constraints, and skills that will have and will not have. Then we have decided the parts and where to find them and how to find them, how to create them. And now we have to decide about the software. And for this, you have to decide the basic skills that your robot needs in order to accomplish the tasks that you want the robot to do. So for a case of the barista, we need to have the following skills, of course. It has to move from one place to another without colliding. So the robot has to figure out where it is and how to move to the place, that the table that it has to bring the order, without colliding with the people, with the chairs, with whatever it is on its way. And then we have to indicate some way which location to go. So the person who is loading the robot with the coffees, it has to have a way of indicating the robot, hey, please go to table number 6. So you have to have a way of doing this. Could be by a voice. That was not the case for the barista. But those basic skills have to be very, very simple. And it had to be very, very clear, very defined. So how to move from one place to another without colliding. That's it. So how to indicate the location to go. This is very, very simple and very clear. Everybody understands this. So let's decide some basic skills for your robots that you would like to have. In your case, you have indicated before at the beginning of this talk. Tell me, which basic skills your robot will need? So if you have, so I see here on the chat that you have some discussion about some products and prices, etc. That is nice, but I would like to know if you have any skill that you think that you may need for example, for a robot that patrols around the house, for example. So for this, we'll need a skill. It's for patrolling around the house. You will need, for example, to move outdoors, following a predefined trajectory. That's one case, for example. Then Jorge says, for the cleaner, he says, Jorge, avoid obstacles like sofa, table. Okay. So in this case, you should specify a little bit more. So if it's avoid obstacles, then it's very good. Avoid obstacles in general. If you want to avoid very specific type of objects, like objects that have legs, then you should specify here. So objects with legs, like a table, sofa, or whatever. Then here, Chris Massier says, recognize users. Oh, let me copy. Recognize users. Okay, yes, because this may be very basic for your robot. If it has to talk to the people, if your robot has to talk to people or to provide information to people, it has to recognize the user some way, maybe with a face, maybe by voice or something. Bianchi says, detect human presence. Okay, yes, perfect. Human or not human, perfect. So let's detect human presence, for example. And then driving path segment or straight line. Okay, Matt, it is very similar to move outdoors. Alexander says, robot need to understand its position. Okay, yes, already said for Barista. For the shopping cart, it should be able to calculate a specific distance at which to follow the person. Okay, that would be follow a person. Epson Warco, let's say follow a person. Follow a person. Okay, so I don't know why I cannot copy paste anymore. So for some reason I not allow. Yeah, okay. Follow a person. Okay, so that's the last spot that we have. Follow a person. Let me write it down like this. Okay, great. So thank you very much for all the other contributions. Let's keep moving. So thank you very much, Manju, Shubham, Chris Basier, again, thank you very much. So let's continue, okay? So you have an idea what I mean, decide basic skills. And then once you have decided that, then we need to know where we can find the software for doing this. So what we are basing this product is on using ROS. So we want the robots to use ROS software, to be ROS based. Why? Because ROS, as I said before, ROS provides already off the shelf many things, so many things, and every day any other person is developing new stuff, new software for ROS. So if you allow your robot to work with ROS, you have a lot of the work already done that you can use. So this identify the ROS software to use is the ROS software that allows you to do the functionality that you have before. For example, in our case, we needed the robot to go from one place to another while avoiding obstacles. This is already done by ROS. It's called the ROS navigation stack. So you go there, you put your navigation stack on your robot, and you are done. And then we identify another thing that is the ROS bridge. So in order to identify this ROS software to use, you may have to do certain research. You may have to talk to somebody in case that you don't have the whole knowledge for that. But it's very likely that whatever you want to do in ROS, it's already provided there. So I would suggest you that you look for the different types of things that robots can do, like is navigation, that is the case, manipulation, that is grabbing things around with grippers, etc. Perception, that is about detecting people, recognizing them, following them. Or the other one is, those are the three basic skills that a robot can do. So if you look for those subjects on ROS on the web, you will find the ROS software that can do those tasks, probably, is very likely. So in this case, we have another functionality that is called ROS Bridge. And ROS Bridge is a specific software to connect to a web server. And why is that? Because we need the person who is delivering the coffee to the robot has to indicate the location at which the robot has to move. And for that, we are going to use a web page, very simple web page that contains all the tables. And then when the person does click on one of the table, then this is a web event that has to be communicated to ROS navigation stack. And for that, we are using the ROS bridge. ROS bridge is the bridge between web elements and ROS. So that's why we only needed this software for the Barista. This is a specific case for this. You have to identify the same thing for your case. And then the final step is to identify the software that you need to write. Of course, if you have identified the software functionality that you have, and you have identified the software that already exists for your functionality, then also you will need to identify what is missing there. In our case, it was the web page that is, you can see here on a tablet, that web page can be seen in any device, on a phone, on a tablet, on a monitor, on a computer. So you can see on any place. This is a diagram of the cafeteria where the robot barista is working, and contains the different tables with the numbers. So this is the simple thing that we have built for this barista robot. That's all. It contains two parts, okay? First is the web showing the tables in the different locations, and then a small ROS node that connects through the ROS bridge and then converts the table selected to a ROS navigation goal. So this ROS navigation goal is directly sent into the ROS navigation stack that is already done. So these small parts are making the glue between the final product and what is already exists in software that is called ROS. We are going to see on the next episodes of these webinars how we did this and how you can do that. Okay, so in more detail, this episode 1 is just a general introduction of the whole project, how you have to start, okay, to identify all those things. So what I recommend also always is to reuse always code, hardware, whatever already existing, reuse. And then we finish here with your homework. So what I would suggest is that you follow again this webinar, and then you decide the product that you are going to build. And then follow the different parts and write it down. Write it down and send that to me on as a homework. So if you want me to review or give you some feedback about your possible, if it is possible, if you are missing something, or to correct you in some way. So that is your homework. Review the 3 steps, the 3 parts, and fill all the data for your product, a specific product, and then send that to me. And my email is not shown here, it should be, but I'm going to just write it down very quickly here so you can see. Is Teles here. Okay, so you can send me this to this email your robotic product, the one that you would like to build, the one that where are you going to, which parts are you going to require, if you have found some people that can do the graphic design, if you would like to use this or this software, you would like to build these parts, these small parts that need still to be built that doesn't exist, etc. So I will review and give you a feedback. Okay. So just would like to, before we finished, I would like to tell you that we are promoting a ROS Developers Conference that is going to apply. It's going to be done in July on 7 and 8. It's an online conference in the same way as this webinar, but with the difference that all the attendants will be practicing ROS in real time using a web platform that contains ROS, and it's already, you don't have to install anything. So it's for 500 people only, and those people will attend practical classes like the live class that we have tomorrow at 6 at the same time as this webinar. Tomorrow we have a live class about visual states, how to create state machines with ROS. So this ROS Developers Conference is going to be very similar, but with invited speakers that are going to talk about different subjects around the world. And everybody will be connected online. You don't have to travel anywhere. So in case that you are interested, here is the information. And that is all. I have some minutes left for questions. So I'll be happy to answer your questions. So let me know which ones are your questions. I have just a few minutes. So let's see on the chat if somebody, in the meantime, I'm going to drink some water. And I see that the people attending the webinar is talking. When is the next webinar? It's the next Tuesday, same time, same day. Thanks for the webinar. What was your email again? Screen blacked out. Okay, so let me write it down here. Here, my email address on the chat. Here it is. Then we have Vijayasri. We have a question: how to integrate machine learning with ROS? That's a very good question. Then it depends on which kind of machine learning you want to do. So 2 weeks ago, I think it was 2 weeks ago, we released a live class teaching how to integrate OpenAI reinforcement learning with ROS. So go to our YouTube channel and look for the OpenAI video that describes how to use OpenAI reinforcement learning for this. In case that you would like to have deep learning integrated with ROS, then we have another course in our academy. We have an academy at this address. Academy is robotigniteacademy.com, and there we have released it's a course that teaches how to integrate deep learning TensorFlow with ROS. Then more questions. Let's see. Shubham, he says, what's the basic difference in various ROS-based version? So no, there is no basic difference. So it's just new functionalities, errors that have been solved, and some additional functionality that has been added. But the core, the way that the nodes are communicated, the commands, etc., it remains the same. There was a big change between some versions, old versions and the modern ones. That was the way that the packages of ROS were compiled. Now we are using Catkin for compiling, and before it was been using ROSmake. Now it's a lot more powerful, but a little bit more confusing, but that's basically the differences. So don't worry too much about the versions. Don't worry, unless you are doing something very, very, very specific. Jorge Vargas says, Rosifying the components is too difficult. Well, it depends. It depends on the hardware you are working with, but usually it's a lot of work. It's not that it's difficult, but it's a lot of work to make it work, and that works everything. So I don't suggest you that you go on this, but it's up to you, of course. Some name in Russian that I cannot read. It says, "Do you know how to create a track?" A track. What does it mean? A track? Sorry, didn't understand this question. Then Epson Warco has answered. Chris Maker, the tutorials on Robotic Night Academy are great. Oh, thank you very much, Chris. Thank you. Vijayasri says, thanks for the answer. Okay, great. New TensorFlow with ROS. Yes, that's available at Robotic Night Academy. Exactly. Okay, so I see that there are no more questions and I have to leave. It's been a pleasure to be with all of you. And please send me your questions, or you can write down questions beneath this video afterwards so everybody can see it. And of course, if you like this kind of videos, please subscribe to our channel and press the bell and give us a thumbs up. There will be another, yes, Chris, there will be, see you next week. There will be another episode with more concrete examples. So we are going to work. Exactly. That was more descriptive. And the next one is going to be more hands-on with the software. Okay. Okay. So thank you very much, everybody. Thank you, everybody that is saying thank you there on the channel, and see you next week on this, or tomorrow on the live class, same time. Cheers, mates. Thanks a lot.